anytime. And Russ and I will field the questions, but we're going to wait until the end to answer those questions. Anything that we may not have time to get to, we will make sure to follow up. There will also be some other just general follow-up items, and you can expect that via email after the session. So one of the things here that if you've ever been to one of my presentations that I've either moderated or been involved in at maybe one of the trade shows or a different Structure Tech webinar, you know, I always like to start with a joke. And this one's really, really good, Russ. I think it just really hits home to what we're getting at, and it's all dealing with making smarter investments, and that's what this presentation is about. Let's make smarter investments to make these parking structures last. We know parking structures are very challenging to maintain, and they can be very, very expensive to maintain. So when we're making these investments, we want to make them as smart as possible, make them last, to make these structures last, get the overall lowest life cycle cost. So, you know, the joke is, and I think, Russ, you've heard this a few times, but it's this business owner. He's very, very successful, has a very, very successful manufacturing operation, and things are going great. And he has a daughter, and this daughter is getting married. And after the wedding, the father, the business owner, decides, you know what, I'm going to make an investment into my family. And this new son-in-law seems like a great guy, you know, just a really, really great young gentleman. And he's excited. He wants to make the investment into the family. So what he decides is that he's going to surprise them. But what he's going to do, Russ, is he's going to make this new son-in-law part owner of the business. He's actually going to bring this guy on as a partner. And that's very, very exciting news for sure. So he brings it to the new son-in-law, and he says, son, you know, you're part of the family, and I really want to welcome you into this family. So what I've decided to do is make you partner of my business. And as part of your partnership and ownership of my business, I want to get you really, really involved on the accounting and the overall financial management of the business. And the son-in-law says, well, you know, Dad, I appreciate that. I really do. However, you know, sitting in an office and looking at the accounting files and managing the financials of this business, it doesn't really seem like something I would like to do. It doesn't really get me very excited. But thank you for making me partner. And finally, the dad says, well, son, if you don't like finance, that's okay. What we can do is I can make you the overall operations manager. So I want you back in the plant managing this operation in such a fashion that it's just flawless, it's seamless, things are running really good. And the son-in-law says, well, Dad, I appreciate that as well. However, I don't want to work in the back of a plant. You want me to work back in the plant and manage the operations? That doesn't seem very exciting to me either. And finally, the father-in-law says, well, son, I've decided to make you owner. You don't want to work in finance, you don't want to work in an office, and you don't want to work in the plant. What in the heck am I supposed to do with you as a partner? What good are you for a partner? And the son-in-law says, well, you can buy me out. So not a very, very smart investment there for the father-in-law, not a very, very fair trade. So what he was going to have to do is buy the son-in-law out. Not a very smart investment. He really should have known what he was getting himself into, what was of interest to this new son-in-law of his, and made him partner. So that's what Russ and I want to do. We really want to that we're totally clear on the common challenges, so preventable problems that we're experiencing with these structures. We want to look at some common mistakes that facilities professionals make in the management of these structures. And we want to look at strategies for obtaining funding for these structures. And then ultimately, to close it, we want to look at how to develop a really solid maintenance plan to extend the life of these structures. So, you know, Russ, what are we looking at here?
All right, we're going to primarily focus on looking at parking structures. This is a freestanding open parking structure. We're also going to be looking at plazas. And you might ask why, and they have many factors or conditions that are common to each other. Some of the commonalities that we see is, as I said, you know, they are often intermixed, they are multi-use, They also have extremely aggressive deterioration environments. We salt them like crazy to keep people from slipping and falling. They're exposed to any weather that we have out there. This also results in similar problems and similar repair needs. So starting with the parking structures, there's a couple of different types. There are the freestanding ones, which are basically, they're on their own. They may occupy a whole city block, a half a city block, whatever, but they are parking ramp, as they're quite often considered, single-use parking only. Other types are multi-use, where other office space or retail or some other use may be incorporated into it also. Along with that, they may be either open or closed, and what that affects primarily is what the ventilation requirements are for them. Some of the factors that affect which way they go may be the land cost. If it's an urban setting, multi-use are more common now. Age, open freestanding parking structures common many years ago, but with the land costs to justify that. Code compliance may require multi-use. The retail demand may require that there be more retail at grade level and so forth. Architectural influences can also affect that. The first one we looked at here was freestanding, built in the early 70s. The second one here was built in the mid to late 90s. Same city. They were about a block apart from each other, but it was more of the change in the land costs and the development interests of the city. They wanted to get more mixed use in there. You can see there's retail at grade level, and there's residential at second level with parking above. Looking at plazas, the basic types are going to be pedestrian only, vehicular, landscaped, or a combination of the three. This is a Midwest structure. It's a combined system. The red there is not actually brick, it's a stamped concrete pattern. The red brick pattern and the bollards define the driving lane. The rest of the plaza is pedestrian only. This one is a pedestrian only with landscaping. The landscaping to the right is on the plaza. It's not adjacent to it. Those are very large box planters. So it's a combined system. This is a major utility in the southeast part of the U.S. This is a hospital courtyard. Again, pedestrian and landscaping. It's a northern Midwest area. Central Midwest area, this was a pedestrian plaza with small box landscaping. It's essentially an employee break area. When you're looking at these systems, there's a few different basic design systems that are used. There's precast, pre-stressed, post-tension, cast-in-place concrete. There's conventionally reinforced cast-in-place concrete, steel frames, or hybrid mixes of these systems. So how do you know what you actually have? This first one here is a two-way flat slab. You can see there's drop panels at each of the columns that thickens up the slab system. Typically, these are a maximum of 30 by 30 foot grid on the columns. They're quite often used where there's office space above, hotel space above, where the column locations for the structure above may dictate the need for where they are down in the garage. These typically are very thick floor slabs, 8 to 14 inches thick. The reinforcement goes in two different directions. And as I said, it's common in older structures or under other structures. This is a precast garage. Precast means that they are individual units that are pre-manufactured elsewhere and shipped to the site for assembly. There's many welded and bolted connections. There may literally be miles of joint sealants in these garages. Typically are a 5 to 6 inch thick floor system. Easiest way to think of these is giant Tinker Toys. This is a cast-in-place beam and slab system, conventionally reinforced. These are identifiable by the close spacing on the beams. These are generally in the 8 to 12 foot spacing on the beams. The floor slabs are generally in the 5 to 8 inch thick range. Conventional steel bars are used to reinforce the floor slab. That's as opposed to this, is a cast-in-place post-tension reinforced beam and slab system. And the biggest identifiable feature here is the much wider spacing on the beams, which opens up the feeling of openness in the garage. You're looking at 20 to 30 foot spacing on those beams. Makes it much easier for light distribution and so forth. These include a high-stress cable buried in the beams and tendons to achieve that. So some of the common problems that we see in both plazas and parking structures, we're looking at leakage, concrete deterioration, and salt contamination. And these are actually all interrelated. We'll be seeing more in a minute, but the leakage brings salt into the concrete. The salt in the concrete accelerates deterioration, and it becomes a vicious cycle as the deterioration becomes worse. It's a quick overview of some of the types of deterioration. Joint sealant failure. Joints can fail either at the bond, which is an adhesive failure, or within the joint sealant itself, which is a cohesive failure. This can result in leakage down into lower portions of the structure. The leakage can actually occur at failures within the concrete itself. This is through slab leakage at fine cracks in the concrete. By the way, this is also an example of another type of beam and slab. This is called a pan joist system, very close spaced, maybe 2 to 3 feet apart. But you can see that it's actually enough leakage going through there to cause small stalactites to form.
Yeah, now that's not recent leakage, Russ.
That's long-term ongoing leakage. A symptom that you may see sooner than that is something like this, which is a large area staining on the underside of a floor slab where moisture is coming through in fine cracks and so forth, and contaminating it with salts that leave a residue on the surface when the water evaporates. So where's the water coming from? You start getting deterioration on the top side, you get cracking. A deterioration like this will act like a reservoir and hold water for a long time, which promotes the water to work its way out through the floor slab. Unfortunately, at this one, the deterioration occurred right at a drain, so the water didn't get a chance to even get into the drain.
Now, is there a reason for that, or would that just be more of a coincidence that it's around the drain?
If the drain was set so that the water could not get into it real easily, the water would tend to saturate into the concrete, cause freeze-thaw damage, cause corrosion damage, and progressively become deeper. The drain may have been only an 1/8 to a 16th inch above the surface to start with, but as the deterioration progresses, it turns the concrete around it into rubble, which acts like a small lake.
So we really need to make sure that there's positive drainage, good drainage.
Absolutely. The long-term effect of these is that the water that's coming through the slab starts to affect other structural elements. It can affect the beams, like you saw in some of the other pictures. It can also migrate over and start affecting columns and start corroding reinforcing steel in the columns. In here is water coming through to cause corrosion of the bottom reinforcement in a floor slab, which is effectively the ceiling of the floor below. This concrete, some of it had fallen out, some of it we ended up taking out as a safety precaution. Other form would be freeze-thaw deterioration. When moisture gets into it, it causes fine cracking when it freezes and expands. In the southwest area, very similar appearance can also come from a chemical reaction with the aggregates called alkali-silica reactivity. Very similar response as far as the deterioration of concrete.
So Russ, I mean, most often when problems seem to be noticed, or at least when we get brought into it, it's when there's drips, so those active leaks, right? drops, which could be some of those concrete deterioration issues. You've got falling concrete, or there's a trip, an occupant, someone going to and from the parking structure trips and falls. So really those are the three, key areas where we're really starting to notice these problems.
Yeah, if you think about it, that quite often is also the point at which lawyers are called.
That's a good point. That's a good point.
So, why aren't problems noticed earlier or addressed earlier? And as far as why they're not noticed earlier, is they are quite often hidden. They're not always that noticeable. Parking structures, the way they're laid out, people very easily become disoriented as far as exactly where in the garage they are. So even if they want to report it, they have difficulty telling you where it is. It's also not a destination for most people. It's just where they're going to put their car on their way to doing something else. It's essentially a utility. It's very easily ignored. As far as why it's not addressed earlier, that usually gets down to two items: either maintenance budgets or misconceptions about the long-term durability of concrete. Despite people knowing that it does deteriorate, there's still a very common thought that it's made of concrete, it'll last forever, and it doesn't. Just a quick example of some of the different layouts that can be found in parking garages as far as why people can be disoriented. Some of the most common types include single-threaded helices, double-threaded helices. There's even triple-threaded helices. There's side-by-side helices, camelbacks, end-to-end helices, side-by-side helices, split levels, all kinds of configurations that are all considered standard and typical and easy to get lost in.
Yeah, it can be very complex, very confusing. Russ, I probably shouldn't mention this, but so confusing, in fact, that even when you and I were visiting that large hospital, parked in that big parking structure to do the evaluation, even you and me, Russ, you're a high-end 30-year parking consultant, structural restoration consultant. Took us 15 minutes to find it was pretty complex. But
thank you for reminding me of that one.
Yep.
I almost managed to forget it.
So what are we looking at here, Russ?
One of the other reasons we're looking at this is previous or temporary repairs can also hide long-term ongoing problems. In this particular garage, the owners came through and put up very nice stainless steel gutter system underneath active leaks, but they didn't address the leak itself. So the leakage continued. Continuing on, what are some of the causes of leakage? Can be joint sealant failure, could be cracking of the concrete itself, could be problems with waterproofing membrane systems, or as we saw in some of the other pictures, drainage problems. As an example of a joint sealant that has totally lost bond, so it's an adhesive failure. There's no bond on either side. You can pick it up with your fingers. This is an example of a joint sealant that has cohesively failed, which means it is split down the middle. And this is an example of one that was just absolutely put in wrong. It actually is spanning between two different sections of two adjoining garages that had soil in between them, and they tried to span across the two systems, over the soil, and into the next one.
Interesting.
As we said earlier, drainage problems create reservoirs of water that exacerbate the problem by keeping the water there for a longer time without draining away. In a plaza system, this is a good example of how you can tell if you have problems with drainage problems within the plaza system itself. If vegetation can grow up through the plaza is holding moisture down where you're not seeing it, and that's what's feeding the roots.
So this wasn't like a lead movement or sustainable movement?
No, it was a hidden condition. Most of the rest of the plaza still looked good, but these indications were showing up all over the place.
Interesting.
The sources of the water may be joint problems. It could be fine cracks. It could be within the drain system itself. This particular one, they were having problems with the drainage. We did some test openings and found that when the drains were installed, in an effort to protect the drain when they poured the concrete, They wrapped the sub-level drainage with burlap and plastic and left it there when they poured the concrete. So it totally blocked off any access of the water down at the membrane level from getting into the drainage system. Other problems can be not tooling joints soon enough or not placing them quite over where you need them. So you end up with a parallel joint running right alongside the joint you put in. You could also have problems with not having adequate numbers of joints. Concrete, when it cures, naturally shrinks. That's why we put joints in very large structures, very large pores. It's common also to include what's called pore strips. In this case, it was about a 5-foot wide strip, actually closer to 7 foot wide, as I recall, that is left open when they pour a floor slab. This particular garage was poured in quadrants, so strip opened between each quadrant and then came back later to infill it. Unfortunately, they didn't provide frequent enough joints in the pore strip, so the pore strip created its own joints by cracking. As far as the concrete deterioration itself, some of the things that cause or lead to it is corrosion deterioration, which is corrosion of embedded steel within the concrete, flexural or stress cracking, which can be related back to the original design, freeze-thaw conditions, thermal movement, which is the actual cycling, annual cycling or daily cycling based on thermal changes, material interactions, which may be, as I talked about, in alkali-silica reactivity or mixing different building materials when you're constructing it and how they interact. Use of de-icing salts is a major factor. A lot of these work together, as we said before. When you start getting joint sealant failures, water is moving into the structure. Quite often it's carrying de-icing salts with it. It reaches embedded connections or embedded reinforcing steel, begins corrosion. When that steel begins to corrode, the corrosion byproduct materials, the rust itself, wants to occupy a volume of approximately 7 times that of the original steel. That puts a lot of expansive pressure and forces on the concrete surrounding it. Concrete is great in compression, but not so good in tension. If this is allowed to continue and there's enough steel, you can result in problems like this, where the amount of steel at this particular joint, in order to fix it, we had to tear out about a foot back on each side to get in new concrete and anchor it all back together. Some of the common mistakes that people run into when they're trying to deal with these, lack of expertise is, and we're not talking about lack of expertise of the person managing the structure, it's the lack of expertise of people who are coming in to try and address the problems. Your contractor, your consultant, if they don't have the background in these particular types of problems, they may recommend or perform repairs that are not appropriate or don't address the base cause of the problems.
Yeah, Russ, and I think especially when it comes down to those different types of structures, I mean, like you said, we introduced 3 to 4 different types of structures, whether it's precast, post-tension. Those are really different systems, and they need to be treated as such.
That's correct. Going along with that, as far as internally, some of the common mistakes is not keeping copies of the construction documents. A lot of times that's out of your control. If the structure has changed hands multiple times, they may have gotten lost in the sale process. But if at all possible, you want to make sure you keep a copy of those available, because that's the first place that you can go to try and find what a potential cause is for a problem going on. The other one is having a copy of floor plans readily available. And even if you don't have the actual construction documents, even hand sketches of a structure keep available in your management office, so when someone comes in and reports a problem, or one of your staff is out working in the garage, notes a problem, they have a place to document where it's occurring. And that way you develop a library of where things are going on. You can identify patterns of problems that are developing. So what hides problems and makes it difficult to address these? In plazas, if it's a vehicular plaza, it could be the type of paving system that's out there. If it's a pedestrian plaza, you're still going to have pavers or something along those lines that's an architectural feature. The main difference between these is whether it's like a concrete overlay or asphalt overlay or something like that versus individual paver units that are put down. If it's a landscaped one, it could just plain be soil, grass, and trees hiding the problems. Also, the type of waterproofing system that's used. We've run into many occasions where a loose laid waterproofing system was used. If moisture penetrates that membrane system, it can travel a lot of distance before it finds a place to move through the slab. It's very difficult to find the source. In parking structures, it may be a traffic topping. It may be areas that are limited access, mechanical rooms, electrical rooms, and so forth. Could be dripping into there and people aren't seeing it on a regular basis. In this particular case, we had a client that had a parking area alongside their office building, and every time it rained, the water was migrating down the surface of the parking surface, and where you see that bump out in the building, right adjacent to that, there was a office space in the level below. For roughly 17 years, they had an ongoing heavy flow of water into that office every time it rained. And it would keep doing this for 2, 3, 4 days after the rain stopped. They had contractors in there multiple times trying to address the problem. And again, it was the contractor not knowing what was going on and not being able to address it properly. They ended up coming in and putting in a gutter system. It wasn't stopping the water, but it was catching the water before it became too annoying to the person in the office, draining it down and tying it into the footing drains below. So it was a retrofit temporary fix that did not resolve the problem. It just handled some of the symptoms. What we actually found was going on was that this was a plaza-type system that was used in the parking structure surface. Water was getting in underneath. The drainage system was only set up to take water at the surface level, so the water would actually come down to the bottom edge of that plaza, come up through the floor slab, cracks, and eventually work its way into a drain. But that left about 15 inches of water head in that was collecting under the slab, and that was over time working its way through failed joints at the membrane level.
So, Russ, when it comes down to extending the life of structures, I think what we've developed is there's really 3 questions that you need to be asking and really need to be looking for. Number 1 being, initially, do I have a problem? Doing a really proactive evaluation of these types of structures to first just identify, are there any problems? Do I have a problem? After that, you've identified some things, Russ, and it's, I know I have a problem, but how bad is it? What's the extent? Are these widespread issues or are they small maintenance items? And after that, I know I have a problem. I know it's bad. What's the cost? I mean, really, what's it going to take to invest, budget, start planning for it to get these issues remediated and keep these structures in really, really good shape?
Okay, so this is the start of developing your long-term maintenance program. So first of all, it may be a relatively new structure. It may be a structure you've just recently purchased. Whatever the reason, you don't have a lot of history on it. You need to identify, do I have a problem? And this is a very basic evaluation. It's a survey. You're looking at the structural elements, what the waterproofing type is, what the drainage system is, the electrical and mechanical systems, limited non-destructive testing. And by that I'm talking what's referred to as a chain drag, or what ASTM refers to as an acoustic impact test. If you have a little bit more history on it and know you have a problem, but you're not sure how bad it is, then you're looking at a little bit more comprehensive review. And it's going to start with a review of the maintenance history, which goes back to what I was talking about, keeping records of reported problems with floor plans that you have, doing a comprehensive visual review, representative non-destructive testing, so not necessarily chain dragging your whole structure, but taking 20, 30, 40% and then prorating it based on what you find there to establish quantities, doing some limited destructive testing, and by that I'm referring to possibly small test openings if it's a plaza type system, or you've got some hidden conditions, possibly some core testing to find out what the compressive strength of the concrete is, what the air void structure is, basically what its durability factors are, and chloride ion content testing. And chloride ion content testing and some of these other tests, if you have that information from previous testing, by all means try and keep that where you have it available. It's invaluable in future work and possibly eliminating the need for future testing. All this information is then put together and documented to identify deterioration patterns. If you're at the point where you know you're going to be doing work in the next year, 2 years, whatever, then the cost becomes a lot more important of a factor to narrow it down, get it into a number that you can present for budgeting and cost approval. So if you haven't done some of this before, it may be just an upgrade to that. It may be doing it new for the first time, but it's a comprehensive review of the scope of potential work, increased documentation for quantities, possibly more extensive structural testing depending on what's going on, maybe test excavations, corrosion testing, petrographic analysis, which is, again, it's a microscopic testing of the concrete components. Other non-destructive testing, depending on the conditions that are going on, may be appropriate.
So, Russ, and we'll look at some really good examples, and I just want to spend a little bit of time on this one. It's really how to obtain funding. And what we came up with through really some interaction and discussion with a lot of our existing key customers on really a tried and proven process that they've been using to get this funding. So we have an actual webinar on this. We've got a write-up on this. It takes an hour to get through all 5 steps, actually. So what we can do is we'll send that out as a follow-up link. We just gave it. It's really, really informational. It's really good. It's come from other Fortune 500 customers, key hospitals that have been really successful in getting capital budgets approved. So I'm just going to give the highlights here, but we will send out that link. So if you do have an interest in learning more about that 5-step process, I would really encourage you to watch that. So number one, Russ, it comes down to establishing that relationship with key financial decision makers. Who is it that's making the decisions? Who's going to be a really big influencer on letting us get these parking structure budgets approved? After that, Russ, it goes down to what you're saying and what we're going to continue on is the surveying and the assessments of the parking structures to really have that solid understanding of what are our conditions, how bad are these conditions, and what do we need to do moving forward. After that, utilizing that data to really put together a solid prioritized program based on the overall conditions. So rather than assessing it, going after a $10 million parking structure restoration program in 1 year, let's prioritize, let's chunk that up into manageable chunks, looking at a 5-year program if possible. After that, we all have to put our salesman hats on, and we really need to pitch that case to the key financial decision makers. There's a lot of strategies that we do outline for that. We're really coming up with a solid value proposition of how it impacts the organization and how it aligns with the organization's long-term goals and objectives. And from there, tracking of the results. Hey, we did year 1 of the parking structure program. It created impact in using that to sell the following year. So strategic 5-step program that we've developed with a number of our customers who've just been, really wildly successful in getting budgets approved, and it's something that we definitely want to share. And it's very important to this topic because, as Russ has been saying, parking structures are very, very, they can be costly to maintain. They're not a destination. They're not a real showpiece for an organization, I should say. So it can be hard to get funding. So we really need to be strategic. We need to make sure that we're doing the right things to ensure that we're making the right investments at the right time so we can really be smart in the investments in the management of these structures.
Yeah, as I've had many clients comment to me, it's much more glamorous to get donations for an MRI suite to be constructed than it is to get funds for maintenance.
So Russ, what is this, high-end piece of equipment, cutting-edge technology that
this high-tech, cutting-edge technology you see before you is the basic tool that is used in developing documentation of problems in a parking structure. We always just refer to it as a chain drag. ASTM actually refers to it as an acoustic impact testing device. And essentially, the theory behind it and the way it works is the chains, as you're dragging them along, you're swinging this, getting some impact from the chain against the concrete surface. When those drag across where the concrete has started to delaminate, which means it's separating into layers, and that's generally caused by corrosion of embedded steel, those layers act like a drum head and give off a very distinctive sound. And you can actually get a pretty good feel for how deep those are by the tone of the sound that you get.
Yeah. Now, Russ, it's very important to understand the sound, and if you don't mind, I'm going to tell this one as well. But so Russ was telling me earlier on in his career, he was training a gentleman, an older gentleman, to do this acoustic impact testing, and they were looking at a really, really big parking structure, and they split up. They had a team. They split up. Russ said, okay, you're going to go up, do these top 2 floors. I'm going to go down. I'm going to hit the bottom 3. We'll meet up after lunch, and we'll just kind of compare notes, and we'll see where things are at. And it was a really effective way to do things. So, Russ, the way I remember it, you were going through this garage, swinging this heavy piece of, chain drag acoustic impact device, and you found just a ton of stuff, right? You found a ton of stuff, and then you guys met up halfway through the day, and you're like, wow, that was one of the worst parking structures I've ever evaluated in my life. And this guy said, really, Russ? I didn't find anything up top. I thought it was good. And the guy had low battery on his hearing aids, and he wasn't hearing the variations in the noise. So that was a tough one.
That was.
So.
But this tool that you see right here is one I recommend, anybody that's working in parking garages or plazas, make up a copy of this. It really doesn't matter too much what the frame materials are. You just want a relatively heavy chain hanging off that so that you get the good impact. As you're sweeping the floor with this, you hear the sounds of the concrete deterioration, and I don't know how well it shows up in your pictures, but the green lines you see there is where we were documenting delamination and deterioration of the concrete. So we're marking it on the floor plans, or on the floors with paint, and documenting it on the floor plans. So you're going to be documenting concrete deterioration. You're also going to be documenting problems with joint sealants that you notice, documenting conditions where there's water coming through the floor slabs, staining or spalling of the concrete beams. This photo here is actually showing water backing up in a test opening in a plaza system. So that type of information would be documented in an evaluation. Problems with the reinforcement. In this particular case, we're actually going to be looking at the structure that this photo was taken from in a few minutes, but this was an old, early style post-tensioning system. It was what was referred to as a paper wrap button head post-tension system. As you can probably imagine, paper does not provide a tremendous level of protection against corrosion. So you can see there was, in this one is the same structure. doing testing on it to see if they were still stressed. Essentially, if you can separate the wires with a screwdriver or lift them with a small pry bar, they are no longer in tension. Visually, just looking at it, again, this is a plaza area. You got vegetation coming up at the joints. It's an indication you've got water retained in the system, so it's not draining properly. You're getting edge deterioration. No vegetation showing here, but the water at the joints has led to freeze-thaw damage of the concrete alongside the joint. Documenting ponding water areas, deterioration of floor panels, of adjacent architectural features, all the things that could give indications as to where the deterioration source is coming from, and helping you identify the quantities established with it. Again, in plazas, you got varying elevations. How the water is handled and drained out of there can have a big impact. If the waterproofing is continuous and monolithic, is a major factor. Retrofits after original construction can cause major problems with continuity of the waterproofing. So all those types of items are what are evaluated during a structural evaluation for you. Once that information is collected, then it's important to determine what's the proper way to address the problems. And the repair methods that are needed are going to be dependent on what the structural design was. As we talked about, there's precast, there's cast in place post tension, there's cast in place conventionally reinforced, and so on. These all have different weak points, if you want to call them that, different criteria that affect them. We also need to look at any phasing requirements that may be necessary to maintain access and usage. Also, if it's a paid-apart structure, it may be important to look at phasing to maintain cash flow so that you can afford to do the repairs. So starting off with a blank floor plan, like we were talking about before, keeping one on hand so that you can note things as they're identified. We went through and did this chain drag process. We went and did the visual examinations, undersides of floor slabs, beams, columns, and so forth. And the information that we documented from that showed the areas in yellow are traffic areas, and the areas marked in that reddish orange were areas of major deterioration. And unfortunately, they have a very overlapping configuration there. And what we found when we went in and did some test openings and got into the repairs is that the concrete floor slab was supported by concrete encased steel beams, and the concrete was actually lifting off the beam because of corrosion on the top surface of that beam. So the repair ended up being, for this particular one, cutting back far enough to get to structural or to solid concrete, providing head and anchor studs on the steel beam, casting it all back together and waterproofing. In this particular garage, this was a structure that was used primarily by executive suite personnel. They were very concerned about dust control, both for preventing dust getting on other cars that were parked in there while the work was going on, but also they had a major data center in this complex. So we had to look at a system there that would be removable when traffic had to go during the day, but could be put back in place quickly to allow work to start as soon as vehicles left at the end of the day, and then they worked through the night. So this is a curtain type system that was dropped down while they were working, rolled up during the day. We also made sure that protection was provided at all doors, so dust wasn't going around at door jambs and so forth. All HVAC had to be filtered. But no matter what you do, there's always people that don't get the message and leave their car there. I mean, this person may have been on vacation, I don't know, but you have to be prepared to protect vehicles that are still there so that the work can continue. In addition, we had to provide, because of the dust barriers, the breathing became very hot and difficult, so powered filtered air systems were used to maintain acceptable breathing conditions for the contractors. When all the work is done, you end up with a very nice looking surface. This particular one had a traffic coating on it in addition, provided once the concrete structure was taken care of, the waterproof coating was put back in place. Even if minor cracking develops after the fact, because of the type of system it is, the waterproofing membrane gives you long-term protection against leakage. Looking at the structural factors that impact how you have to do the work, the most extensive areas of deterioration are going to be where there are concentrations of reinforcement. And that goes back to what we talked about earlier, where water carrying salts starts attacking the reinforcing steel, causing corrosion, which breaks apart the concrete. So the repairs, depending on how far they've gotten, may start with limited spot repairs. If it's been going on for a while, there may be large strip repairs over beams and so forth. It could even go up to as much as full slab replacements. Here we're looking at a typical floor plan of a precast parking structure, a double T type design. The areas that are most susceptible on something like this is going to be where the top steel and the connections are to the steel frame, or to the structural frame, which is going to be at the perimeter, at the interior beam lines, and at the individual connector points along the joints. In a beam and slab design cast in place, the areas that are going to be most susceptible are over the beam lines, both at the center bay and over the individual bay joint or bay beams. That's where the reinforcement is at a high point in between the beams. It's down lower. In a two-way system, you're actually looking at two different concentrations. Along the beam lines in both directions, there's very high concentrations of steel, and at the center point of the bay on the bottom side, where the blue area shows, there's also high concentrations of steel, so you get a lot of ceiling deterioration in those areas. Structurally, those are both very significant concerns. In the waterproofing system, joint sealants are probably the biggest factor. Random cracks showing up that are not sealed. Surface sealers can impact leakage. Traffic coatings and membranes. Supplemental drains can also be installed to minimize ponding areas. And these are generally more effective than trying to cast thin wedges of concrete to try and divert the water. Along joints, as we were showing on some of the earlier pictures, you can get cracking alongside of joints. You may address the main joint itself with a sealant and find that a fine crack has developed alongside it. So depending on conditions, it may be necessary to install traffic coatings or similar materials alongside of joints. This was at an expansion joint. This was at T-to-T joints. There was a lot of deterioration going on adjacent to the joint, so we made sure we came in about a foot wide on each side of the joint and took care of that problem. Other concerns to think about at the surface, you want it to be a non-skid surface. You don't want pedestrians slipping. You don't want cars doing, what do they call it, a Tokyo slide or Tokyo drift.
Tokyo drift, yeah.
You want it, on the roof level, you want it to be UV resistant. Obviously, you want it to be moisture resistant. ADA does not really have any specific requirements other than they want it to be non-slip and so forth. There used to be some ASTM standards that addressed non-skid surfaces, but those have actually been repealed because they just were not definitive. Other things to be aware of would be load issues. If you're looking at a plaza, you don't want to change the weight that's on it, by going to a different system, without evaluating it. Concrete overlays on a parking structure, without taking that into account can be a problem. And you also want to make sure that you're maintaining proper drainage slope to drains, adding drains as necessary. One common thing that happens a lot is people will put in raised patches, either intentionally or not. They divert water. If it's intentionally, hopefully it's to a drain. Sometimes they're put in just to provide additional protection for reinforcement in a patch. If that's not taken into account, they can actually cause ponding water. You want to make sure the water gets to the drains. You want to make sure you got a surface like this that's got some texture to it and has adequate surface roughness to it to provide the traction that you need. Plazas in particular, again, we were talking about some of the types of plaza surfaces that are used: soils, protected membranes, paver systems. All of these have different system weights associated with them. If you want to go from a soil to a concrete architectural surface, you got to make sure that you're balancing that out or providing additional supports as needed if it's going to be heavier. Protected membranes, same way. If you're going from a membrane with a lightweight fill on top of it to something that you want to be able to have traffic going over, you got to take a look at make sure the materials are compatible and the loads are compatible. You want to make sure that drainage is not blocked. And as I mentioned earlier, you don't want any discontinuities in the membrane. A continuous uniform membrane is the goal in any waterproofing on a plaza.
So Russ, I mean, I think this is a really, really important point, and I want everyone to, I guess, just really be aware of, when we're looking at maintenance planning, developing that internal maintenance program, doing that general review of structures and systems. I mean, what types of checklists can we use? How often should we be doing these types of general overviews of parking structures?
Well, there's lots of different checklists out there in the industry, from the National Parking Association, Precast Concrete Institute, various other ones that are just general in nature. You can also develop a checklist that's specific to your project or your structure. And we should be looking at, defining it by, what should be looked at daily, what should be looked at weekly or monthly, semi-annually and annually. So there's generally, around 4 periods in general that you're taking a look at your structures. And it can be divided down into general housekeeping, preventive maintenance, and system long-term planning. Some of the examples here, daily housekeeping might be looking at trash pickup, just elevator cleaning. If you have a lavatory in the structure, parking equipment maintenance, your gate access and control systems. Semi-annually or annually, you may be looking at window cleaning in elevator lobbies, light fixture cleaning and lamp replacement, doing a structural review for surface conditions. You may be looking at semi-annual washdowns, to help get some of those salts out of the deck before they have a chance to cause major problems. Looking at joint sealants on a semi-annual or annual basis. Some of these types of things you want to do on a regular basis so that when repairs are done, you're doing complete areas so it's easier to document, as opposed to just the spot repairs that you may do throughout the year anyway on joint sealants. You may go in and do spot repairs of 6 inches of leaking joint, but as those start building up, you're going to want to replace them in an entire area. So you're developing a planning and maintenance cycle, which gets into the next part. Materials that are used in structures, for the most part, have a fairly defined useful life cycle. Sealants in the joints on a roof level, you may be looking at 6 to 8 years. Down in the structure where they're not exposed to ultraviolet problems, you may be looking at more 8 to 10 years. Sealers are a penetrating material, so it's not so much a wear and durability issue on what they're exposed to. It's more just long-term chemical breakdown, how long they're good for before it should be reapplied to help provide the best protection. Traffic coatings, you can get a 5-year warranty on those. Some of them will let you get a 5+5 where you get it inspected and a new top coat put on and you can get 10-year warranty. But in general, the coating itself is generally good for the 8 to 10-year lifespan. Expansion joints, similar. But once these are identified and you are tracking the conditions, you can be planning ahead and budgeting as part of a maintenance cycle to get the funding prepared and ready for it.
So Russ, in closing, let's look at a project profile of a project that you and team have recently completed. Now, this is a really interesting one. I think it was just done within the last few months, and it was actually a $10 million overall parking structure restoration project. So can you just give us an overview here of the scope of work?
This was a parking structure for a teaching hospital out east. It was originally a 3-level garage built in the mid-60s. In the early 70s, they decided to increase the structure by adding 6 levels of nursing school on top of it. A few years later, they decided they needed some more parking. So in the space between the original garage and the nursing school, they managed to squeeze in 1 more parking level. Over the years, salts and so forth caused problems with these parking structure floors. Deterioration was becoming very widespread. This actually is the one that we were showing those pictures of the tendons. Unfortunately, we found that almost 60% of the tendons were failed. The repair options were reviewed and discussed with the client, and it was determined that, particularly since they have 6 floors of nursing school above, they could not afford to just demo and rebuild the structure. So that we had to selectively demolish the parking floors only, keeping the beams and columns, and reconstruct it with a new post-tensioned floor slab. As part of this project, they also modified the grade level and actually created a new grade level entry-exit point. As you saw from some of the shoring there, since it took a little time to be able to go from the testing and evaluation stage to being able to have the work under construction, there was an extensive program of temporary shoring just to provide protection and continued usage of this garage. The whole project took about 15 months once construction started. It was a very labor-intensive, very complicated project to keep everything moving smoothly for the client and for the contractor. It turned out very well. Client is very pleased. The structure is essentially, from most viewpoints, it's essentially a new structure.
That's incredible. Well, thank you, Russ. So we did have some questions here that came in, and I know we're running tight on time, but we want to get to as many of these as possible. So, Russ, first one that we're going to hit on here. So we looked at a number of parking decks there in the slide. Do you know if any of those have utilized a DCI corrosion inhibitor? And what are our thoughts on potentially preventing erosion?
DCI, that's basically a calcium nitrate material. It chemically prevents the formation of corrosion. The way that works is, the amount of material that's put in can be defined as far as under certain corrosion conditions, how long it will provide protection. It does eventually get used up, but it is a very effective, relatively low-cost procedure that can be done. It's done as an admixture to the concrete. Like I say, it does provide long-term protection. I have nothing against it. It works very well. The biggest factor is it has to be done at the time of construction. There are some other materials out there now that can be applied after the fact during restoration or repair work, but it's a little bit different material.
Good, thank you, Russ. Another one that come in, we had a couple kind of along these same lines. So what types of ice melt and ice removal, ice and snow removal?
Ideally, none. Calcium chloride and sodium chloride are the most common ones out there, and also the most destructive. What we usually recommend is trying to work with a blend of salts and sand. That does have the difficulty of trying to make sure the sand doesn't plug up the drains. There are some salts out there that are combined with material called CMA, which is calcium magnesium acetate. It actually will let the salts work at a lower temperature. The difficulty with those salts is that rather than just flat out melting the snow and ice, it turns it into more of a slush that has to be, plowed out still, or, tire traffic kind of splashes it off to the side. In critical areas, there are potassium chlorides, which is more expensive. There's ureas that are more expensive. So they are generally very limited usage materials.
Okay, good. Now, Russ, this is a question that came in, and the question is, are there some reasonable annual cost per square foot for preventative maintenance that we might want to allocate for our facilities departments?
Yeah, for a new structure, we generally recommend 20 to 25 cents a square foot. You may not use it all on an annual basis, but if that money can be rolled into a maintenance fund, so that, at 5 years, at 10 years, and so forth, you have a fund built up that you can draw from. That's ideal. If you're starting from a point where there's already deterioration going on, then I recommend that you bump it up into the, depending on conditions, 35 to 50 cents a square foot range.
Okay, good. Thank you, Russ. Okay, so we did have some more questions come in. We will do our best, or we will get to all questions, and we will respond to those. But in closing, Russ, for today, thank you so much for sharing all the information. I think you did a really, really good job. And what we wanted to do was really support in identifying those costly and preventable problems with these structures that we talked about. Look at some of the common, mistakes that facilities departments can make when managing these structures. Touch briefly on strategies for obtaining the funding to maintain the structures, and ultimately developing a really, really solid preventative and proactive maintenance program to extend the life. So thank you so much for joining. We hope you enjoyed it. Just as a note, we will be doing educational seminars across the country. We call these forums. We have 4 scheduled for this year as part of the Structure Tech Building Construction Technology Education Center lineup. We'll be in Naperville, Illinois, on May 3rd. We'll be in Farmington Hills, Michigan on May 10th. We'll be in Dallas, Texas on September 13th. And to close the year, we'll be in Louisville, Kentucky on November the 1st. So if you have interest in those, please let us know. It's a really, really great lineup. We do full days touching on a really multitude of different technical and facility topics. Great opportunity to get together with your peer group. We're typically looking at, corporate facilities professionals, healthcare facilities professionals, educational facilities professionals, really coming together, sharing, learning, and networking for a really great day. So if you have interest in that, please let us know. If you have any other questions, you have any other comments, or if you have a story to share, please let us know. But again, thank you so much for joining. Russ and I really had a good time presenting, and we hope that you got a lot out of it. Thank you so much, and have a good day.